Pleasant good morning to all. I am Dr. G. Nagalalli, working as an assistant professor in the Department of Electronics and Communication Engineering in Mahindra Engineering College. So I am here to present a topic under digital circuits in the subject digital electronics. So first we see what is digital electronics. So digital electronics is a study of electronic circuits that are used to process and control digital signals. So before start of deep learning about this digital electronics, first we have to know where the digital word arises. So during the Second World War, we come across the word they called digital. Okay, so before that what they use for communication, they make use of analog. So we know as in the universe, everything is analog in nature. Analog in the sense, each and every signal is continuous in nature. So for processing those analog signals, we have so many demerits. That's why we are moving forward to the subject called digital, right? So now we can talk about what are the advantages of digital electronics over analog signals. So here the digital signals are more accurate and reliable. So it can be easily stored, processed, and it can be transmitted. It consumes less power. So when we talk about the power consumption, it plays a very major role nowadays. So it consumes very less power. Then the digital electronics are easier to design and manufacturing process is also made easier for us. Now we are entering into our topic digital circuits. So a digital circuit is a circuit where the signal must be one of two discrete signals. So in the last slide we talk about the analog signals, right? So what we see, the analog signal is nothing but it is continuous in nature. Comparatively, when talking about the digital, it is contrast to the analog signal, that is it is discrete in nature, which means the signals may be either 0 or 1. Okay, so it is not a continuous signal. So digital circuit make use analysis of the discrete signals. The digital circuit uses the transistors to create logic gates in order to perform Boolean logic. We are going to see about the types of digital circuits. So the digital circuit is broadly classified into two. One is combinational circuit, the second one is sequential circuit. Let me see what is combinational circuits. A combinational circuit is a circuit in which the output is depend upon the present input. In deeply we can say, so the combinational circuit is going to produce an output. Okay, it is going to perform some logical operations. So it will produce the output depending upon only the present input. So the present input is very must when we talking about the combinational logic circuits. So again the combinational logic circuit is classified according to their applications or working operations. So combinational logic circuit is broadly classified into three categories. So one is arithmetic and logical functions, second one is data transmission, the third one is code converters. So in arithmetic logical functions we are having some examples of, we are using the combination circuits for performing add, addition, subtraction, and for performing the comparator operations, and for programmable logic devices. In data transmission, the combination logic circuit, it is used to increase the efficiency of the communication process. Some of the examples of data transmission combination circuits are multiplexers, demultiplexers, encoders and decoders. Next for the code converters, 7-segment display. So how to design this combinational circuit? So it is having some certain steps in order to design the combinational circuit. So the step 1, first we have to understand the problem. After understanding the problem, we have to estimate how many inputs and then how many outputs are required for the particular circuit. This is the step 1. In step 2, we have to reduce. So for that we have to first make the truth table. So after designing the table, then we have to reduce the expression using K-map or using the Boolean algebra function. Finally, we are going to design the combinational circuit by using the logic diagrams. So here I took an example. So digital in the sense we talk about zeros and ones. So here I took an example of a binary addition. So here 4 different cases are here. for adding 0 and 0, 0 and 1, 1 and 0 and 1 1. So for the first three cases, it is producing the result only sum. There is no carry is generated here, right? So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. Yeah. For the last case, it is producing, so 1 plus 1, it is producing the result of 1 0, which means it is producing the result as sum and then it is generating a carry, right? So for this, I am going to design a combinational circuit. So using the steps. So first we understand the problem, right? So it is having two inputs. So I am naming the input as A and B. Then it is going to produce the output as sum and carry. Okay. So I am naming the input and output. So the A and B is nothing but an input. The sum and carry is nothing but an output. It is going to perform a logical operations. Then it is going to produce the output, right? So this is the truth table we derived. So as we seen in the previous slide, when we add for the first three cases, it is producing the output as sum output as 1, right? There is no carry is generated for the first three cases. The last cases in 1 plus 1, the sum is 0 and then carry is 1. So for this table, we are going to make a K-map, right? So here for each output we have to design the K-map. So for sum we have to make a K-map, for carry also we have to make another K-map. So using the K-map we are going to reduce the expression. So we reduce the expression, then we have this logic diagram for sum and carry out. So this is about your combinational circuit. Next we move on to the sequential circuit. What is sequential circuit? How it is varying from the combinational circuit? So whereas combinational circuit we talk about, so it is going to produce the output depending upon the present input. So you have to underline the word present input, right? Whereas when we talk about the sequential circuit, so it is going to produce the output depending upon the present input and then previous output. So here we add another block, you can able to see that memory elements. So which means it is going to store one bit of data, that is the previous output is stored, then it is going to process the present input and then previous output, then it is performing some logical operation, then it is producing the output. So this is called as a sequential circuit. Yes, a sequential circuit, or it is also a digital circuit that store and use the previous state information to determine their next state. So here also, as we seen in combinational, sequential is broadly classified into synchronous sequential circuit and asynchronous sequential circuit. So before we talk about the synchronous asynchronous, the sequential circuit is make use of clock signals. Sequential circuit is producing the output depending upon the present input and the previous output, right? So how the output is getting changed only depending upon the clock signal. Okay, so the clock signal controls the output of the sequential circuit and it determines when and how the memory elements change their output. So here for the discrete signal, the clock input is 0 and 1 is given. Here we are having only the two states, whether the state is 0, state is 1. Synchronous sequential circuit. So here the output depends on the present and previous state of the input at the clocked instant. So here we know the sequential circuit make use of present input and previous output for producing an output. Here the synchronous means we have to know about the clock instance. Using clock signal, the state changes will occur across the storage elements. So here the synchronous sequential circuits are very stable. Asynchronous sequential circuits. The sequential circuit which do not operate by clock signals. So that is called as an asynchronous sequential circuit. So then how the output will change? Here these circuits will change their state immediately when there is a change in the input signal. So when synchronous, it doesn't change when output signal until it requires a clock signal for changing their output. In asynchronous, it will, when the input changes, immediately it changes the output signal. So this is summarization. So here we seen about combinational circuit and then sequential circuit and its classification. So here we are comparing the combination and then sequential circuit here. So here the output depends only on the present input, whereas the sequential circuit depends both present input and the previous output, that is present state, right? Next, here there is no feedback path is present, but here the feedback path is present. And then in combinational circuit, it doesn't require any memory. In sequential circuit, it requires some memory space. That is, it can able to store 1 bit of data. And then combinational circuit doesn't require any clock signals, whereas sequential circuit, it produces the output depending upon the clock input. So combinational circuit is easy to design. Comparatively speaking with, so sequential circuit is little bit difficult to design the circuits. So the possible questions are, so what is combinational circuit, what is sequential circuit, then they will ask you list the types of sequential circuits, then we have to compare combination and then sequential circuits. Thank you.